Okay, so we did look at one-sided limits, but now we're going to have a detailed look at one-sided limits. So the graph of y equals f of x is shown. What is f at -1? F at -1 is, can't be both. What is it? 1. Why? Solid dot, right? Open dot does not include solid dot does. What is f of 2? 3, right? Open dot, not solid dot, yay. What is f of 3? And there's no disputing that, right? The function f of x is not continuous when x equals -1 and when x equals 2. What is the limit as x approaches -1 from below or from the left of f of x? So as x approaches -1 from the left, the limit is 1. What is the limit as x approaches -1 from above or from the right? 1. Oh, sorry, right, 2. Wrong line. What is the limit as x approaches -1? Does not exist. Why? Yeah, so the two one-sided limits have to be the same for the limit to exist. So if the limit as x approaches a from below of f of x is not equal to the limit as x approaches a from above of f of x, then the limit as x approaches a of f of x does not exist, right? And there's enough space there to spell it out. Does not exist. All right, let's do the same thing with 2. So the limit as x approaches 2 from the left or from below is negative. You got it in front of you, right? So I'm not going to scroll it up. -1. The limit as x approaches 2 from above or the right is -1. And so the limit as x approaches 2 of f of x is -1. Right? So if the two one-sided limits are the same, then there is a limit, right? It does exist. Or, if the limit as x approaches -a from above f of x equals L, which is equal to the limit as x approaches a from above of f of x, then the limit of x as approaches a f of x exists, and the limit as x approaches a of f of x equals L. Number 5. Is the limit as x approaches 2 of f of x equal to f of 2? So what was the limit as x approaches 2? Where's that? That's here. So is that equal to f of 2? No. Is f of x continuous at x equals 2? No. What is the limit as x approaches 3 from below? -2. What is the limit as x approaches 3 from above? What is the limit as x approaches 3 of f of x? Is the limit as x approaches 3 of f of x equal to f of 3?
Yeah.
Yes. Is it continuous then?
Yes.
Yes. Okay, so in order to be continuous, then it must also evaluate at that point, right? So if the limit as x approaches a of f of x exists, and the limit of x approaches a of x, f of x is equal to f of a, then f of x is continuous at A. Determine each limit. So we want the limit as x approaches 2 from above, or from the right, of the root of x minus 2 plus 6. So what are we going to do? We're going to stick in a 2. Make that too big, right? And then add 6, and then what do we get? 6. The limit as x approaches 2 from below of the root of x minus 2 plus 6 is... So what happens if we're coming from below? 2. So like 1.999. What are we going to get? 1.999 minus 2 is going to be very close to 0, but negative. So what's the problem? You can't do that, right? So if you're approaching 2 from below, you're below 2, and then you subtract 2 from it, you're going to end up with a small, as small as you like, but negative value, which you can't do because you cannot take the square root of a negative. So what are we going to say about this limit? Does not exist, right? Yeah. Sure. Okay, why does it not exist? Because x must be greater than or equal to 2. And if we're approaching from below, then we are less than 2. And then this, right, could blow up, right? Or just think about where that starts, right? If you graph the root of x minus 2 plus 6, it starts at 2 and then goes. All right, what is the limit as x approaches 3 from below of the absolute value of x minus 3 over x minus 3? Well, okay, so it's an absolute value, right, which translates to its piecewise function, right? So if we're, where's the magic point for this thing? When x is equal to 3. Okay, so 3 or above, it just is what it is, right? It's x minus 3. Below 3, what's the function? Right. Move that over a bit. Okay, so this is what we get, right? If you are below 3, then the absolute value function for this is defined as the negative of x minus 3, right? Okay. Now, what can we do? Can we simplify it all? Yeah. Well, okay, so this takes out this, leaving 1s. We've got the limit as x approaches 3 below of negative 1, which is just negative 1. Okay, now you try the next one. So now the function, since we're on the other side of 3, is just x minus 3. And so what does this limit evaluate to? 1. So what can we say here? DNE does not exist, right? Why? Because left side limit, right side limit, not the same. So this limit does not exist. Example 2, for f of x is equal to negative x minus 2 if x is less than or equal to negative blah, blah, blah. Is y equals f of x continuous? Okay, I don't think we can tell just by glancing at it, but if it's not continuous, where would we want to be looking? What values of x we want to look at if we think it might not be continuous?
-1 and 1.
Yeah, -1 and 1, right? Because this is where we're going to change, right? Because -1, we're here, but so when x equals, so what are we going to say? We will say y equals f of x might be discontinuous when x equals -1 or x equals 1. Right. So we're going to have to figure that out. Right? Now, how do we do that? Well, we're going to look at the left side limit and the right side limit and see. So determine the limit of limit as x approaches -1 of f of x. So here's what we're going to do. The limit as x approaches -1 from below of f of x. Which would be equal to the limit as x approaches -1 from below of which function? So which function defines that? Or where does that lie? If we're going -1 from below, which of these three are we using? First one, -x minus 2, right? So -x minus 2. Let's throw that in brackets for the heck of it. Which is equal to what? Well, we can put a -1 in there, right? I mean, there's no 0 over 0 or anything like that. So that'll be -1 minus 2, which is equal to 1 minus 2, which is -1. Okay. Now what? Now we have to look at the limit as x approaches -1 from above, right? Of f of x, so we'll leave ourselves some room. Which function is it for approaching -1 from above? So it's just going to be x, right? And what's that going to be equal to? Put -1 in there. -1. Huzzah! So what do we say about the limit as x approaches -1 of f of x is equal to -1? And now, same thing with 1. Okay, so I'm going to pause this. Didn't record anything.
You gotta do it all over.
So here's the sketch. And I don't know where we stopped recording, so we'll just run up here and say, okay, just look, see, numbers, fill them in, do stuff.
I think it was the last page.
Yeah, I think it was the last page. I don't remember. So you might be seeing some of this again, and then I'm going to back up a page, and here's this one, so look at it, see the answers, and just in case, here's this one, and then really just in case, here's this whole thing all over again. Okay, just pause if you need to. If you don't understand it, come to Wise Time, that's what it's there for. It actually is recording now, yes. Occasionally this happens.
Could you go over yesterday's lesson too, just to be safe?
No, that one's up. I saw that one. All right, example 3. If g of x is equal to x squared plus 2k, if x is less than 3, and it's equal to 2x plus k squared, if x is greater than or equal to 3, then determine the value or values of k if g of x is a continuous function. All right, so what do we know? If g of x is a continuous function, then what? Well, let's go a little more formal than that. You're right, but let's lead up to it. then what are we going to say about, say, the limit as x approaches 3? From below, not the inverse. The limit as x approaches 3 from below must be equal to what?
The limit is x approaches 3 from above.
Is equal to the limit as x approaches 3 from above. Okay, so now we go to yours, right? Which means that what? X squared plus 2k has to be equal to 2x plus k squared when what? When x equals 3. Okay. So this is the y, and now this is the okay. Right, so let's do that. Put in a 3 for x. 3 squared plus k is 2 times 3 plus k squared. Ah, it looks quadratic. Yeah.
That should be plus 2k.
Plus 2k. I think I could copy stuff there. 2k, 2k, 2k. Thank you. Okay, so what's that become? K squared minus 2k minus 3 is equal to 0. Okay, so we plug in the 3 for x into the now corrected equation, and we solve for k. Okay?
Okay.
Okay.
No, no, you can't.
UK? No, now we're in a whole different country. Okay, get out some blank lined paper, because we're actually going to intro trig limits. Oh, we're gonna do like 5 quick examples, because then we have a lot to do. And look how much time we have. Lots of time. So,
No, you can't.
oh, this time you're gonna get it. The notebooks we left for the semester. Okay, this will be reasonably quick. So one thing, actually it's intro to limits of trigonometric functions. Limits of trigonometric. So I hope you still know your unit circle. But more than that, I hope that I still know my unit circle. Well, actually, it's just the unit circle. I don't have one that's separate from yours. It's just so, number 1. Always in radians. Okay, so that's not really number 1, but that's number 1, right? So when we do limits of trig functions, it's always in radians. Okay? Won't work in degrees. Okay, the real number 1. What is the limit as x approaches pi by 6 of sine x? So you might say something like, well, the sine function is continuous, right? And if it's continuous, then the limit as x approaches pi over 6 of sine x is simply equal to the sine of pi over 6. Yeah, 1/2. Yeah. I got to get back into thinking that, right? Because it's which this goes on to imply, right? So in general, the limit as x approaches c of sine c is equal to, or sorry, of sine x. So the limit as x approaches c if sine x is equal to sine c, right? It's a continuous function, so it doesn't matter what value of x you put in there or value of c. So what do you think this might be? Yeah. So the limit as x approaches c if cos x is equal to cos c. Okay, let's step it up a smidge. Number 2. Limit as x approaches pi over 2 of sine squared x minus cos x. This kind of goes back to those limit properties, right? So the difference, the limit of a difference is the difference of the individual limits, right? And being as this is continuous, then we know that this is simply going to be equal to sine pi over 2 quantity squared minus cos pi over 2. All right, what's the sine of pi over 2? 1. So it's going to be 1 squared. What's the cos of pi over 2? 0. So that's just going to be 1. Okay, 3 more. Maybe 4. Limit as x approaches 0. Okay, what's the limit of a quotient? Limit of quotient is the quotient of the limits, right? But the limits in this case, because it's continuous, is just the function evaluated there, right? So this is simply equal to sine 0 over cos 0, which is 0 over 1, which is, yeah. Yeah, let's call that 3. 4. The limit. What if it's cos x over sine x? Yeah, because then it's going to be cos 0 over sine 0, which is 1 over 0, which is does not exist, right? And it's not equal to does not exist, it is does not exist. 5. The limit as x approaches 0 of sine x over x. Looks innocuous, but it's going to rule the rest of your life for this. So, what's that going to be? Well, it's going to be sine 0 over 0. What's the sine of 0? So it's 0 over 0. What happens when you have a limit that's 0 over 0? There's a chance we should look at this. So here's how we're going to look at this. First, we're going to just pause this. So here's sine x over x. So what do you think the limit is? 1. Yeah, good. So as we approach from the left, we like 0.999. Undefined, which we knew, right? Okay. So that limit is 1. It's okay. We graphed it. Graphed and looked at. And we see the limit as x approaches 0 of sine x over x equals 1. The proof is on page 303. And since we introduced trig early, right, because it's on page 303, we'll be jumping back and forth like into the trig section and out of the trig section. Okay, so you really want to look at the timeline as to, okay, which questions do we have to do? And we'll do one more. I know, and I lied, because I want to throw in one more. But it's exactly like this one, only different. The limit as x approaches 0 of okay, the limit as x approaches 0 of cos x minus 1 over x. Okay, so what should we do? Well, we're going to do cos 0 minus 1 over 0, which is 0 over 0, which begs further review. And there's the graph of cos x minus 1 over x. Yeah.
How are we supposed to figure out the answer to the previous question if we don't have a graph calculator?
On your formula sheet, which I'm going to deliver to you in mere seconds. Pretty good, huh? I've got the answer at hand. Okay, so what's this? Obviously going to be 0, right? I could get it to be. Come on. No? Oh, you can't get there. Come on. Alright, it's not going to go there, right? But we know it's undefined there, okay? So that is, so the limit as x approaches 0 of cos x minus 1 over x is equal to 0. And these two are so important that they're on the formula sheet. This is your own souvenir copy of the formula sheet, right? You can put your name on it, you can write on it, you do all kinds of stuff on it. We're kind of done with it.